Hi, my name is Shahroz Ahmed, and in this video we'll do the topic on electricity for AS or A-level physics. So in this topic we will particularly discuss about the resistors in series and parallel. We'll discuss the series and parallel circuits. We'll discuss the electrical energy and power. So let me just give the heading. It's about the electricity, and first of all we'll discuss the resistors in series and parallel. So resistors in series and parallel. So what happens if we put the resistors in series and parallel? So what happens to the total resistance, in fact? So for example, if we have three resistors that are attached in series, 1, 2 and 3. So this is basically the series arrangement of the resistors. Let's suppose the resistance of each resistor is R. Let's suppose this is R1, this is R2 and this is R3. And if we want to find out the total resistance, I'll write it as RT. That would be equal to R1 plus R2 plus R3. So in series they simply add up. So if we have the resistance of each resistor as 10, 20 and 30 ohms, then the total resistance will become 10 plus 20 plus 30. That would be equal to 60 ohms. So 60 ohm will be the total resistance of these resistors that are attached in series. Now let's discuss, or let's see the connection of these resistors in parallel. So let me just draw a circuit where the resistors are attached in parallel. So this is the first resistor, is the second resistor, this one is the third resistor. So these three resistors are attached in parallel. This is R1, this is R2 and this one is R3, and over here we are measuring the total resistance from these 2 points. So the formula for finding out the total resistance is 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. So by using this formula we can find out the total resistance of these resistors in parallel. So for example, their resistance is 10, 20, 30. So our total resistance will become 1 over R total equals to 1 over 10 plus 1 over 20 plus 1 over 30. So when I'll add them, it will become equal to, let me just add them, 1 over 10 plus 1 over 20 plus 1 over 30. So that will become equal to 11 over 60. But this is not our answer because we have to find out RT. So I have to take the reciprocal on both sides. So I'll take the reciprocal of both sides, so it will become 60 over 11. So that will be my answer. That will become equal to 5.45 ohms. 5.45 ohms. So now you see the total resistance is less than the smallest resistance in the circuit. So this is what happens in parallel circuits. The total resistance of the parallel circuit will always be less than the smallest resistor. So this is it for the series and parallel circuits, resistors in series and parallel. Now we will see the series and parallel circuits. Series and parallel circuits. So in series and parallel circuit, the main features of these circuits is to discuss about the current and the voltage. So let's discuss for the series circuit first of all. So in a series circuit, what happens is the current remains constant in a series circuit, and the voltage divides in a series circuit. So let's suppose we have a circuit. This is the positive terminal of the battery. Over here we have the negative terminal, and 2 resistors are attached in the circuit. This battery is of 12 volts, and let's suppose 7 volt is being dropped over here, and we have to find out the voltage that is being dropped over here. So because in series the voltage divides, because 7 volt is being dropped over here, so the voltage over here will be equal to 5 volts. So the sum of both the voltages will become equal to 12 volts. Now let's see the current. So for example, the current of 10 ampere is flowing through this circuit. So the same amount of current will pass through both the resistors, that is 10 ampere. So 10 ampere will pass through this resistor and 10 ampere will pass through this resistor. So this is what happens in a series circuit. So now let's discuss the parallel circuit. Let me just erase it quickly. Okay, so in the parallel circuit, let me just draw a sample circuit in which I have a battery with a positive terminal and a negative terminal, and there are two resistors that are attached in this circuit. This is resistor 1, this is resistor 2, and the current is being flowing through this circuit. So let's suppose 10 ampere of current is being flown through this circuit and the voltage is 12 volt. Now in parallel circuit, remember that voltage remains same. The voltage remains same in a parallel circuit, but the current splits. The current splits in a parallel circuit. So if 10 ampere is the total current, so when the current reaches over here, some current will pass through this resistor, some current will pass through this resistor. So if 7 ampere of current has flown through this resistor, then the remaining 3 ampere will flow through this resistor. But because the total voltage across both the resistor is 12 volt, so there will be a drop of 12 volt on either resistor. So the voltage will not change, but the current will divide. And the more current will pass through such a resistor who has less resistance, and less current will pass through a resistor who has more resistance. After that, we have to discuss the relationship between the voltage, current, and the resistance. So in order to explain that relation, we have to use a law that is called Ohm's law. So let's see what Ohm's law is. Ohm's law. So Ohm's law states that the current flowing through a conductor is directly proportional to the voltage, and that current is inversely proportional to the resistance of the conductor. So Ohm's law becomes I equals to V over R, or in simple terms we can say V equals to IR, where V is the voltage or the potential difference, I is the current, and R is the resistance. So this is what Ohm's law is all about. V equals to IR, and this is a relationship between the potential difference, current, and the resistance. Okay, so after this Ohm's law, we have to see that how can we measure the electrical energy and electrical power in a circuit. So for that purpose, I have to draw a circuit, and I'll do some calculations, and from that circuit I will find out the power and energy. So for example, I have a simple circuit where we have a battery that is connected with two resistors. This battery is of 10 volts, this resistor is of 5 ohms, and this resistor is of 20 ohms. So first of all, we have to find out, okay, so in this circuit our goal is to find out the total energy and the total power. So remember that power, if you have to find out the power in a circuit, so power is basically can be found by three formulas. By definition, power is basically it is the rate of change of energy, but in the circuits we use three formulas in order to find out the power. So power is equal to VI, power is equal to I square R, and power is equal to V square over R. So let's suppose we have to find out the total power spent across this resistor. So we need to know its resistance and current or we need to know its current and potential difference. We need to know its potential difference or resistance. Over here right now we only know one attribute of this resistor, and that is its resistance, so that is 5 ohm. Okay, now what we do is we'll find out the power across these two resistors, and then we will find out the energy that is being spent across these two resistors in, let's suppose, 30 seconds. So we have to find out the power, and then we have to find out the energy spent in 30 seconds. So let's find out the power. So before finding out the power, I have to find out the total amount of current that is being passed through this circuit. In order to do that, I will use the Ohm's law. Now Ohm's law says that I equals to V over R. Now I know the voltage is 10 volts, and this R will be the total resistance of this circuit. So now the total resistance of this circuit will be 25, because you see that these two resistors are attached in series. So the total resistance of the circuit will become 25 ohms. So I'll find out the current as equal to 10 divided by 25. So from here I'll get the current that will be equal to 0.4 amperes. So 0.4 ampere is the current that is being passed through this circuit, and the same amount of current is being passed through both the resistors. Now 0.4 ampere is passing through this resistor, and 0.4 ampere is passing through this resistor. Now we have to find out the power. So power is equal to, let's find out the power across this resistor. So that will be equal to I square R. That will be equal to 0.4 times 0.4 times 5. So that will become equal to 0.8. Now the unit for the power is watts with capital W. So the power dissipated across this resistor is 0.8 watts. Now let's find out the energy dissipated across the 5 ohm resistor. Let me just give the heading that we are doing this calculation for the 5 ohm resistor. So the power dropped across this resistor is 0.8 watts, and now the energy is basically equal to power multiplied by time. This is the formula for the energy. So power is 0.8 and time is 30 seconds. So we'll just multiply the power with 30 and we'll get the total energy spent. So that total energy will be equal to 24 joules. So I'll write E equals to 24 joules that is being spent across this resistor. Now let's do the calculation for finding out the energy and power spent across 20 ohm resistor. So 20 ohm, let's find out the power. Power is equal to I square R. So I will remain same because these resistors are attached in series, so that will be equal to 0.4, and the resistance of that resistor is 20. So I'll do 0.4 times 0.4 times 20. So that will be equal to 3.2 watts. So the power dropped across the 20 ohm resistor is 3.2 watts. Now let's find out the energy. So the energy is basically equal to power multiplied by time. So the time is 30 seconds. So I'll times it by 30. So it will be like 3.2 times 30. That will give us 96 joules. So the energy that will be dissipated across the 20 ohm resistor will be 96 joules. So this is how we can use the Ohm's law. We can use the formula for the power. We can use the formula for the energy in order to work out the power, the energy, the current, the voltage, and the resistance in a circuit. So this is it for the topic of for the basic topic of electricity. Now we will head on towards an exam related question that will involve the circuits and where we have to find out the power and the energy. Alright, so here we have an exam related question for the resistors in series and parallel for this topic that we have just done. So it says a student is given 4 resistors of resistance 4 ohm, 5 ohm, 2.5 ohm, 6 ohm and 6 ohm respectively. Draw the arrangement using all four resistors, which will give us the largest resistance, and calculate the resistance of this arrangement. So we know that the resistances add up in series. So what we do is we'll just attach all of these resistors in series. So I'll draw these four rectangles where one rectangle represents each resistor. So this one is 4 ohm, 5 ohm, 2.5 ohm, and 6 ohm. Now I'll just add them up and we'll get the largest possible resistance. So that will be like 4 plus 5 plus 2.5 plus 6. So that will become equal to 17.5 ohm. So this is the total resistance. Now in part B it says draw the arrangement using all four resistors, which will give the smallest resistance. So we know that when we attach the resistors in parallel, then we get the smallest resistance possible. So I'll draw a parallel arrangement of all of these resistors, and then I will find out the equivalent resistance that will give us the total, that will give us the smallest equivalent resistance. So these are the four resistors that I have attached in parallel. So this one is of 4 ohm, this one is of 5 ohm, this one is of 2.5 ohm, and this one is of 6 ohm. So the total resistance will be like 1 over R total equals to 1 over 4 plus 1 over 5 plus 1 over 2.5 plus 1 over 6. So 1 over R total will become equal to, let me just add them quickly. So 1 over 4 plus 1 over 5 plus 1 over 2.5 plus 1 over 6. So that would be equal to 61 over 60. But I have to take the reciprocal because I am looking for finding out R total, RT. So RT will become equal to 60 over 61. So my answer will become equal to 0.98 ohms. So this is the smallest possible resistance, and we got it by attaching all the resistors in parallel. Now let's see for part C. That was B. And now, okay, it says the four resistors are now connected to a battery of EMF 12 volts and negligible internal resistance. So there's no internal resistance of the battery, and so we'll take the potential difference equals to the EMF, that is 12 volts. Now we have to find out the total resistance in the circuit. So we see that this resistor, this whole combination, and this resistor, they're attached in series. So what I'll do is I'll find out the equivalent of these two parallel resistors, and then I'll add up all of them into series. So my total resistance will become equal to 4 ohm plus 6 ohm plus 2.5 ohm in parallel with 5 ohm. So it will give me, let me just write it quickly. So it's 10 plus, okay, now when I'll solve them, it will be like, okay, so when we have two resistors in parallel, then we can multiply them and divide by their sum. So it's like 2.5 times 5 divided by 2.5 plus 5. So it will become 10 plus 2.5 times 5 divided by 2.5 plus 5. That will be equal to 5 over 3. And I'll add that into 10. So I'll get 35 over 3 as the answer. 35 over 3, that will be equal to 11.67 ohms. So this will be my total resistance, 11.67. So I'll just write it here. Maybe I need that in the next part. So it's 11.67 ohms RT, the total resistance. All right, so let's move on to the next part. So the next part is part D. Okay, it says calculate the voltage across the 3 ohm resistor. Okay, now it's a modified circuit, so I don't need that value. So we have to find out the voltage across the 3 ohm resistor. So I have to find out the voltage across this resistor. So first of all, what I'll do is I'll find out the equivalent resistance of this pair. So for that purpose, I'll multiply them and I'll divide by their sum. So it will be 18 over 9, that will be equal to 2 ohm. So the equivalent resistance of these two resistors will be 2 ohms. Now whatever is the drop across that resistor, the same will be the drop across 3 ohm resistor, because 3 ohm resistor and 6 ohm resistors, they are attached in parallel. So whatever is the drop on the equivalent resistor of these two resistors, the same drop will be on 3 ohm resistor. So I'll draw a modified circuit. So it's like this: 2 ohm, 4 ohm, and this is 12 ohm, 12 volts. All right, so this is 2, this is 4, this is 12. Okay, now I have to find out the current in the circuit, and then by using the Ohm's law, I'll work out the voltage across this 2 ohm resistance. So whatever is the voltage across this resistor, that will be the same voltage across the 3 ohm resistor. All right, so in order to do that, I will find out the total current that is being passed through this circuit. So that will be equal to I equals to V over R. So V is 12 and R is 2 plus 4, that is 6. So the total current that is being passed through the circuit is 2 amperes. So 2 ampere will pass through this resistor, and 2 ampere will pass through, the same current will pass through the other resistor. Okay, so now I have to find out the voltage. So the resistance of this resistor is 2 ohm and the current is 2 amperes. So I'll use the Ohm's law to work out the voltage. So that will be equal to V equals to IR. So V is equal to 2 times 2, that will be equal to 4 volts. Now the voltage across this resistor is 4 volts, and the voltage drop across this resistor will be obviously 8 volts, because the total voltage is 12 volts. So now whatever is the voltage drop across this resistor, it means that 4 volt is being dropped across this resistor, 4 volt is being dropped across this resistor, because the voltage remains constant in parallel. So this is it. We have got the voltage, and I think this question is done. Yeah, so this is it for this section, and hopefully you understood that. Thank you.